Hello, and welcome to GitKon. I'm Justin Cormack. I'm the CTO of Docker, and I'm also on the Cloud Native Computing Foundation Technical Oversight Committee. And I'm going to talk about the evolution of collaboration for developers. I'm going to give a kind of historical view and explain how we've come to where we are and how collaboration evolved and what trends and facts are important and what made it get the way it is. I'm going to start with a historical view. I always love to do historical based talks. Everyone who's seen my talks before knows that. So we're going to start in the 50s, but a lot of the interesting things happened in the 90s and 2000s, 2010s. 2010s really gets up to where it becomes modern and we recognize where we are now, and then we're going to talk about what's coming in the future. Open source is an interesting thing. When did it really start? One of the early tracing of it goes back to 1953 with a program originally written by Grace Hopper that UNIVAC sent out with the source code saying, if you want fixes to this, please send us back the fixes. If you want to make it better, send it back and we'll send them out in the next release. And that's really the spirit of open source. But that was, and that was often the culture for quite a long time after that. But the term open source didn't come till much later, of course. Version control is going to be very important in our story. The first version control systems were single user systems, kind of useful for, undoing when you'd done mistakes, but not really collaborative tools yet. Bell Labs built the first one in the early 70s. And we'll see there was a lot of, these became really important as part of a collaboration tool set later on. Another early thing, Ralph Merkle in 1979, who was a cryptographer at the time, invented Merkle trees. These are really the basis for which we use for Git and all the content address stores and the security properties we need in content address stores. And these are what Docker uses in Docker registries as well. So these are kind of important early pieces of technology that will fall into place much later. In the 80s, we really get the beginning of version control as we recognize it now. RCS was quite a popular system for a long time, but CVS came along in 1986 on top of RCS and built a client-server architecture, so you could finally actually work as a team, not an individual, and this was really quite radical. It was the first kind of modern version control system in the sense it was for teams. And you could really use it to collaborate with teams, with a centralized server that the whole team used for their version control. In 1991, we got the first really interesting open source project in Linux. Linux was the first project that was huge scale, globally distributed, and really stretched the limits of how collaboration was working at the time. And we'll see later it drove a lot of innovation later just because of its scale and the nature of the work. I think a lot of the culture we have about working from home and having a remote company being possible comes from the fact that Linux demonstrated that you could have a group of people who rarely or never met each other, but they would still collaborate successfully on a gigantic and extremely successful software project. It might seem strange to call out the URL. I mean, Tim Berners-Lee invented, the whole of the modern web as we know it. But the URL is really radical from the point of view of collaboration and sharing, in a way much more so than, say, HTML and HTTP. It came as part of hypertext and how you get from one place to another on the page. But it's actually a really radical concept. Like, how many times a day do you paste a URL into a Slack or a chat or give it to someone as a way of communicating? And URLs really became a thing about how do we encapsulate the object we're working on, the thing we're working on? How do we pass that state from one place to another? We got things like REST and state transformation and thinking about models and APIs, and all that really came from the one idea of the URL. And it's really quite a radical idea, and we'll see it's still continues to be really important, and it's the basis of a lot of ways in which we actually collaborate and the mechanisms of collaboration. Package management's an important part of the story about how we share content, how we share pieces of software. Sharing source code was obviously the starting point, but often it's convenient to share binaries and built packages and dependencies. And so there was a whole wave of innovation, in the 90s around that, both the language package managers and the ecosystem of Linux package managers. CPAN became the first really wide-scale language package manager and an example to many others. It wasn't the first. It took itself from the tech network, CTAN. And then the things that became RPM and Deb were also pretty early, and there was a lot of innovation there. And these have stayed with us ever since, and they've been a really important part of how we build up software and work together with the broader community to consume software. Collaboration is about culture and how you do things as well as the tools. And I think Kent Beck's extreme programming was really one of the first things. It's really the precursor of Agile. And it came from a kind of philosophy of like, how do we work together to iterate fast on software, understand the customer, understand the process. And it really came from, these different timescales of iteration, from pair programming, in sitting down with someone, reviewing code on the spot, collaborating on the spot, through longer cycles of iteration with the customer. And it's been very influential in many ways. It still affects how we think about these feedback loops and collaboration. But it's also really important just to think about, what's the culture and the way we're working together. That's really the basis for how we use collaboration tools and how we think about collaboration and how we want to work together. In 1999, SourceForge came along, and SourceForge is you can see it as a precursor of GitHub in many ways. It gave, version control to open source projects to consume, had the discovery of projects, and some people still call any kind of Git hosting platform a forge as a generic term coming from SourceForge. So we can see a lot of the underlying pieces of the, how do we discover, how do we collaborate, how do we find each other coming into the ecosystem at this point. Version control systems became an important area. And again, Linux was really driving a lot of this work. Linux was a huge project compared to other projects. It had so many contributors. And so it ran into so many problems with the existing version control systems. And a program came along called BitKeeper that was a decentralized distributed version control system for the first time. And that really fitted well with Linux's model. But unfortunately, it was closed source, and it was given to Linux contributors as long as they didn't compete with it. And some of them decided, Andrew Tridgell decided that was not really acceptable. There was lots and lots of rows and flame wars about this. And in the end, Linus spent a week or so and built Git. And the world changed forever from there, and it became extraordinarily widely adopted. It kind of became the most used system after a number of years. And it's really what we all use today and recognize today. But it was really designed to support the Linux project and its workflows, and it's really just been extended to other use cases since then. A lot of people will be surprised to hear that Nixos is 20 years old this year. I think at the time it wasn't as influential and important as it is now, but many of the ideas it came up with, like how to structure a package management system, reproducibility, immutability, those things have fed back into how we do things now, and it's becoming increasingly widely used. A lot of the ideas seem to have little overlaps with Docker, but as far as I know, there wasn't any real kind of overlap at the time. It was just kind of parallel discovery of many of the same things, particularly around the benefits of immutability and just deploying once. In 2006, when Amazon released S3, I remember being incredibly excited by it. This was the first cloud service, the first product from Amazon Web Services, shortly followed by EC2. But S3 is really radical in many ways. It was Jeff Bezos called it Malloc for the internet. allocate some memory, put stuff in it, refer to it with a URL. This was pretty radical stuff. It comes back to I'll talk about the URL as being radical. This was, let's put infrastructure behind a URL so you can just use it with the URL. It really was like the kind of taking the API and really turning it into something radically new. And it's been extremely influential. Obviously, this is, it was the birth of cloud, and cloud has really, changed the world since then as well. In 2008, a company called Logical Awesome LLC released a product called GitHub. They soon changed their name to match the product, of course. GitHub was interesting in many ways. In some ways, it copied things like SourceForge, but it was much more friendly, easy to use. It came out of the kind of Rails community in terms of ideas about front-end design. It had URLs for everything, kind of incorporated through its structure. So everything was easy to share through URLs. It gave a lot away for free for open source projects. It invented the pull request. So it changed the way we do things. It moved from the kind of Linux model of sharing, having peer-to-peer sharing of patches and diffs through email, and into something where there was a much more centralized model, and you could ask the maintainer to incorporate your changes, or you could fork and build your own thing, but then you could still share back again later. And it changed the model and the way people thought about centralization for a long time. And people joke about it re-centralizing a decentralized service, and it's got some truth in it. But we also gained a lot from that. Again, the things that we'd learned about discovery, and it rode the explosion in Git and open source. 2009, we're getting back to culture and community and working together. The DevOps movement started a little before that, but DevOps days was kind of the days I used to start it with. Getting people together and saying it's not about how we do things, it's about how we work together. Bring developers and ops people together, help them work together, help them build tools to communicate with each other, help them communicate each other by having a common understanding of what we're doing. This became, very influential for a long period of time. It really set the framing around how cloud native evolved and how a lot of our infrastructure toolings evolved. And again, it reflects the importance of the way we collaborate depends on the way we want to work together as a community, and that's incredibly important. 2010 saw the birth of NPM, which, yes, it's another language package manager, but it exploded in popularity. It's become the largest package management system in the world by orders of magnitude. People, joke about tiny dependencies like leftpad that caused all sorts of issues later, but it produced a way of working that was really about collaboration, code reuse at a scale that had not been seen before. And it brought millions of developers into the world of open source and code reuse. And it really, really showed that you could do these things really at scale. And that was, doing package management at scale was qualitatively different, not just different numbers. It's brought all sorts of learning and lessons about things. And it's a really interesting, kind of as a culture as well. And I think that's really important as well. 2011 is kind of where I date the beginning of microservices. It's a very fuzzy term. The term kind of went through various variations, but that's kind of a starting point. But it's kind of the point at which it started to explode. That diagram's from Monzo. It's their microservices by team, and it kind of shows the way we've started to organize things in many places. And that complexity was driven a lot by the fact that, coding was becoming more important, software was becoming more important. We had a lot more people in an organization, and we had to change the way the people were organized and the way teams were organized and the way we work together. And small collaborative units, which is what extreme programming was pushing for, a decade earlier, became the norm. People couldn't work, found it really difficult in many cases to work on giant monoliths They wanted to work on smaller, more self-contained units that they could understand the whole of. And so this became a big change. And Docker itself, it came from that same world. Docker grew up hand in hand with microservices. I think that, they were at the right time for each other. Docker kind of synthesizes a lot of these ideas together. Containers are something like packages, but they're very, very easy to use. But they're not single language like NPM was. So they brought this kind of mixture of containerization, packaging, sharing, build, share, run, that kind of modality, like to a huge audience of millions, tens of millions of developers. And they brought a culture of, simple and easy to use that, is part of the modern software development, stack, and the idea and the way that software is successful now is by being simple and easy to use and being exciting to use. I think that we share with GitKon that kind of culture of building tools that are easy to use and that developers love and that make their life easier. We just released Docker Scout into general availability, and I kind of wanted to connect it to these things. Docker Scout is a tool we've actually been working on for some time internally. It's just gone GA, but it's really a database that actually ties together a lot of these different types of things. It ties together packages, Git, a source code, and containers, to tell you what's inside your container, to help you update your container, to tie back the container to the source code and the packages to their source code. So it's really a database and a kind of metadata graph and store for all the kinds of things that we've been talking about people collaborating over. So it's really also acts as a tool to help you understand the space of the collaboration, which is a really important area. I think we kind of sometimes underestimate how much, we need to actually have a kind of historical database that we can actually do queries and do operations. Git bisect is one of the things that Git brought, and version control brought, understanding your code over history and understanding all the things you're using over history, because it turns out to be really important. Time to reflect on how we got here and where we're going from here. We've really seen it's important that, culture, tools, practice, org structure, all these things grow up together and influence each other. It's not about building a tool to have a better experience. It's building a tool that fits with the changes in organizational structure and helps them, and fits in with the culture of the times, fits in with the organizations that people are trying to build and trying to change, and the problems that people are finding in those organizations. So it's really, you can't just build something, and hope that it'll succeed because it's cool. It's got to fit in. It's got to fit in the zeitgeist, fit in the culture, fit in the way that people want to work. And this is really important. It's important to understand where people's pains are, where people's dreams and aspirations are for building tools. Collaboration in software started with source code, and we can see that from, some of our earliest projects we looked at in the 50s and 70s even were about version control, sharing source code, open source. But then we saw pretty early on that it wasn't just source code we needed to share and collaborate on. Package management became important because people wanted to share, big collections of libraries and dependencies they were using. And then Docker became really successful because people wanted to share whole applications or, components of applications in a more effective way. And so we could really see that sharing and collaboration is at the full spectrum of every kind of artifact and every piece of the process with software. The whole software development lifecycle has collaboration points in it. And as more and more of the world gets incorporated into being software and software eats the world, all of these points have collaboration points, in these different forms of software as binaries and source code and full applications and all the bits in between. And so this really becomes very expansive. One of the things this means is that we need to bring a lot more context to the developer. Um, Often collaboration consists and like interfaces for developers just consist of telling them a lot of things that are happening. But as the complexity grows, we really need to think more about, are we bringing the right context to the developer at the right time? How should we prioritize the different kinds of collaboration they need to do? When should we do things? We don't want to interrupt people when they're in the flow with a notification. We want to, build a system for prioritizing and understanding the work they have to do. A lot of the work we're doing with Docker Scout is really around trying to understand how we bring the right context to developers effectively. Software engineering is really about engineering in a world of constant change, and so managing software over time and over that change becomes really important. You can imagine you're sitting there, inside your organization, and both inside and outside your organization, actually, people are changing software that you depend on, that you use, that you rely on in different ways, and understanding whether those changes matter, how much can be automated, what you need to know becomes really, really key. And I think that we're going to see much more collaboration around this, these kind of developer data models, developer, collaboration systems in order to make that work more effectively. And we're going to end up reinventing a lot of, or modifying, or kind of automating a lot of the tools we've built. We've already seen that, for example, GitHub pull requests that were very much a person-to-person thing have become an area in which people actually collaborate, with the computer. Like there's a bot opens a pull request, and we haven't necessarily worked out how to deal with these workflows most effectively. There's still a kind of should they be treated the same? How should we work with automation? We've seen, through this talk that a lot of the complexity, is being reflected in changes in the organization, and the organization has changed to deal with a huge number of, developers that come in, the huge amount of software that's being built and used and dealt with by the organization. And, if we look again at this diagram from Monzo about their microservices and teams, we see that understanding the state of your organization and getting a view on what's going on as a whole, what's our security posture as a whole, what's the overall state of things, where are the risk points, which teams are, delivering new software effectively, which teams are perhaps not being, stuck with a big update from an old version, all those kinds of facts and, posture of your teams become really important to understand, from the top-down organization point of view. It's quite complex, but this is a data and understanding problem. People are spending more time putting in systems to help them understand what are the services that are in production, and what are they doing, and who owns them, and should they still be there, and how much are they costing, and all these top-down organizational things become really important. And I think that this is a different kind of collaboration. It's a collaboration, kind of often with the business and costing side of things. It's often a collaboration around management structures, but it's also about are things correctly resourced as well. So this is a different kind of collaboration we're seeing being much more important. It kind of goes in waves. We're seeing a lot of cost cutting in many organizations. They're trying to work out if they're spending too much on the cloud. But those kind of decisions about value for money are complex and data-driven decisions where you need to understand, what are the outputs, and what depends on what, and what are the bits of software in your organization that are, high risk or high cost, and what could you do about them? So there's this very much a top-down collaboration, or kind of organization-wide collaboration around this sort of thing that's becoming increasingly important. And again, it's one of the things with Docker Scout, we're focusing on those kinds of areas as well to give an organizational view of your software supply chain. We've seen another thing that's kind of quite sinister in a way, is that supply chain attacks really attacks on the culture and sharing and collaboration mechanisms that we've built. For a long time, everyone would say, open source has many eyes, has fewer bugs, it's much safer even than your own code. But then, people are attacking open source because it's a way into an organization, because organizations are consuming so much open source, and it's become a threat. And that's a threat to the way we work together, the way we collaborate, and our trust in each other. And that's actually really, a difficult thing, that we've all got to work together as a community to strengthen that trust and understand how we deal with these threats together. Data has entered the room. Data has become much more important. Our data scientists, data engineers are all working much more closely with software engineers. We're doing AI ML models. We all work with data in our jobs to a greater or lesser extent. And these kind of issues and collaboration and working together are becoming really important. And at Docker, we're doing a lot of work with AI ML and bringing the container workflows to people who find out that they need it in these areas too. And also thinking about things like, there's data versioning and how to bring data into systems more effectively, more quickly and smoothly are becoming really important as well. And how to version things like models and new kinds of artifacts that are appearing on Docker Hub and other places. As we mentioned before, how should we work with automation is becoming an increasingly important question. As we get more and more AI helping us, that becomes even more critical. At the moment, we've got systems like Copilot that are kind of modeled on a sort of pair programming kind of flow. Well, they're not really quite the same, but kind of maybe that spirit. But what if you had a team of AI helpers that would you collaborate more like a team does? How do we work together to do things like, if they're not fully reliable, how do we build a good testing framework around AI? And so we have new collaboration paradigms that we've got to work out, and I think those are going to be really important if we're going to bring on that dream of extra productivity and extra ability for developers to create more amazing things with more support from the tooling and AI. As a community, we can all work together to bring collaboration, new ways of collaboration, new ways of working as a community together. Tools are part of that. Culture is a part of that. Process is part of that. Organizational structure is part of that. It's a big whole. Sometimes seems scary, but as a community, we can help each other and work together and explore the space of new tools. And it's a really exciting space to be in. And it's really exciting to be at GitKon and work with GitKraken, who are share the same view of us with us as about where we can make collaboration work, how we can make tools work better together. Thanks so much. Great to be here. Hope you enjoyed the rest of the conference.